We will now solve problem 5 given at the exam 2017 in the spring. So this is a statistic problem. We first are given a probability and we're supposed to find means and probability distribution. Afterwards we're given a probability distribution and some events, and we are to work on the probabilities of those happening. So let's start with A. We are to find the arithmetic mean, the mode, and the median. So I like to make a new table. Okay, so the x's are the observations. In this case, 1, 2, 3, 4, and 5. And the f's are the frequencies. So I simply write those that are given in the problem. And xi times fi, that would be how many that are included in those happenings. So it's 96, 54, 48, and 30. The nice thing about this is that we have can make an additional row here. If we sum the frequencies, we get 120, and if we sum the xi times fi, it would be 264. Okay, the reason why I like to do this is that the mean, the arithmetic mean, is defined as a sum over all the xi times fi divided by a sum over all frequencies. And the sum goes here from I equals 1, 2, 3, 4, and 5. Could extend the table with another column if you want to. Okay, so basically this would be x1 f1 plus x2 f2 plus x3 f3 plus x4 f4 plus x5 x5 divided by f1, 2, f3, f4, f5. You don't have to write this, but just so you understand when I'm trying to explain it. So f1 is how many times x1 happens. Okay, so in this case, x mean becomes the sum, which I already have here, divided by the frequency. So I have the number of persons per car on the ferry. This is the number of persons. So we have 36 observations where there were only one. So we get 2.2. That is our arithmetic mean, number of persons in a car. The mode is the one that occurs most often. So that's simply the frequency number which is the highest. So in this case, that's 2. And finally, the median. Ideally, we would like to arrange all of this in ascending order or increasing order, which basically means that we are to write 1 36 times and then a lot of 2's 48 times, and we don't want to do that. That takes way too much time. We are just out trying to find the middle number. Well, there are 120 observations. So the middle would be number 60 and 61. So 60 would be number 60 from the start, and 61 would be number 60 from the end. So the median would be the mean of number 60 and 61. So if we look here, 36 plus 48, that's more than 61. So our middle number will be 2. You can also go the other way. 6 plus 12 gets 18, plus 18 gets 36. So we need some of those also to find the middle number. It's easier when you have a long row and you can simply find those in the middle, but this is also possible. B. Find the probability distribution for the different number of persons per car based on the data set. The probability distribution. So again, we have the passengers. We could also write x1 if you want. We have the frequency. And we have the probability. Like this. 1, 2, 3, 4, 5. We have 36, 48, 18, 12, and 6. And we have the sum, 120. So the probability that we have a car with only one passenger would be 36 out of 120. So 36 out of 120, which would be 0.3. With two passengers, we have 48 out of 120. And then we have 18 over 120, 0.15. And we have 12 over 120, which would be 0.1. Okay, we could have two decimals in all. And then we have 6 over 120, which would be 0.05. And if we sum up all of those, we get 3, 7, 8, 9, 10. So we get 1. And it could be a check simply to see if we have all the probabilities correct. Okay, so that's the probability distribution for a different number of persons per car. Normally we would make like a bar diagram like this, but we're not asked to do that in this one. Something like this. C. For a different car fare, we found the following probability distribution for number of persons per car. And we will use that. The reason why you're given this is that it's not equal to what you had up here. But if you get this wrong, I don't want to build further on that. Anyway, we select a random car and define the following events. So we have 5 different events. And we're asked which of them that are mutually exclusive. And we also want to know which of them that are complementary. Okay, the car has less than 3 persons. The car has more than 3 persons. Okay, so if E1 happens, E2 cannot happen. So those are mutually exclusive. The car has 3 persons. Well, if it's less than 3 persons, it cannot be 3 persons. So those are also mutually exclusive. And E2, the car has more than 3 persons. Well, and it cannot have have three persons either. The car has an odd number of persons. If you have less than three persons, it could be one or two. And an odd number, well, one of those numbers are odd, so we could have E1 and E4 happening at the same time, and also E1 and E5 if there's two persons in the car. The car's more than three persons, well, that's 4 or 5, which is also an even and an odd number. So those can be combined with E4 and E5. Three persons, that's an odd number. So if E3 happens, E4 also happens, but we cannot have an even number. So E3 and E5 are mutually exclusive. And also finally, if it's an odd number, E4, we cannot have an even number. These three could also be written in one like this, because if one of those happen, the others cannot. Complementary events is a little bit different because if two events are complementary, they have to exclude each other, but also if one of them happens, the other has to happen. And we have that with E4 and E5. If we don't have an odd number, we have to have an even number. But it's not like if we test, for example, E1 and E2, we could have E3 also. So if we have three persons, E1 will not happen and E2 will not happen. So that they are not complementary, so that if one doesn't happen, the other has to happen. In D, determine the three probabilities: P, probability of E1, not E3, and E3 given E4. So P of E1, the probability that the car has less than three persons. Well, that's one or two persons. So that would be the sum of the probability for one and two persons. So that would be 0.45. The probability of not 3. The car has three persons. That's the E, and that's 0.25. So not E would be 1 minus 0.25. Notice also that instead of taking 0.1 minus 0.25, you could sum all the others. 1 person, 2 persons, 4 persons, and 5 persons, and that will also give you 0.75. And finally, the probability that E3 will happen given that E4 has already happened. Okay, so E4 is the car has an odd number of persons, so 1 or 3 or 5. So we know that E4 already have happened, and we want to know what the probability is for E3 to happen. Well, that would be 0.25, since that's the one with 3, divided by the others. Which would be 0.5. So in half of the situations where the car has an odd number of persons, there's 3 persons in the car. The reason why I put this up is, let's say you have 100 persons. If we have 100 persons, so we have 100, 2, 3, 4, 5. 1 person, 2 persons, 3 persons, 4 persons, and 5 persons. Then 15 would be 15 of those cars would be with 1 person in it. 30 would be with 2 persons in it. 25 would be with 3 persons in it. And 20 have 4 persons, and 10 have 5 persons. E4 will then be one of these happening. So E4 would be 15 plus 20 plus 10. You need to multiply with 100, so that would be 50. Out of those, if E3, given that E4 has already happened, we said E3, that would be 25 divided by 50, which would be 0.5. So you could use a tree diagram to find it, but you can also do it directly from the probabilities given. Okay, we now select 2 random cars. What is the probability that the total number of persons in the 2 cars is 4? So car 1 and car 2. How many combinations do we have? Well, we get 1 person here, then we need 3 persons in the second one. If we have 2 persons in the first one, we need 2 in the second. And if there's 3 in the first, we need 1 in the second. So the probability that we have 4 persons in 2 random cards. Could define an event A or something, it would be P of A. That would be the probability of 1 person in car 1, 0.15, multiplied by the probability that there are 3 persons in car 2. So that was the first situation. The next one, we have 2 persons in the first one, 0.30, multiplied by 2 persons, the probability of 2 persons in the second. And finally, we have 3 persons in the first and 1 person in the second. So probability of 3 is 0.25 times the probability of 1 in the second. And if you add all of that up, you get 0.165. So that would be the probability.